Okay. So we have a wound field DC machine. Nominal power is given, nominal voltage, nominal current, nominal RPM. The question asks this: what is the power provided at 1650 RPM? I'm not sharing the correct screen. Let me just share my whole screen. Yes, better. So, so step one, what are we missing? Armature resistance. But before that, let us take the equation that we are planning to use. We are planning to use this equation.
Okay.
So for this, what do we need? We need this K3 constant. We need RA. These two terms are missing.
Mm.
And K3 you can get from the UI. So for we need K3 UI equals K3 times I times N. We also need RA. So let me start with RA. We know the simplified equivalent circuit. Consider the nominal operation 70 amps. But before that, we need to get the UI. So
Mm.
UI times I nominal equals PN. PN is given as 14.6 kilowatts. So let me get UI. UI equals 14.6 into 10 power 3 watts divided by 70 amps.
208.57.
208.57 volts.
Yeah.
You can see it is little bit below the UN just like expected.
Mm.
RA equals UT minus UI by IN, which is 220 volt minus 208.57 volt divided by nominal current 70 amps. How much is that? 220 minus 208.57 divide 70. That gives me 0.163 ohms. Let us proceed further. We need the K3 term. Can you hear me?
Yeah, yeah.
Okay. So
UI is
K3
equal to
equals UI divided by nominal current times nominal RPM. Nominal RPM is given to us 1500. UI UI is 208.57 volts divided by 70 amps multiplied with 1500. 208.57 divide 70 divide 1500. So 1500 1 by minute, which gives me 1.98 into 10 power minus 3. 1.98 into 10 power minus 3. What is the unit?
volt per RPM. Volt
Mm-hmm.
per ampere. Volt
Yeah.
RPM per ampere.
Yes, and volt per ampere is ohms. So ohm minute.
Volt per ampere is ohm.
Hmm. By
Ohm minute.
definition, V equals IR, like
Mm.
Ohm's law. So at 1650 RPM, it's the question for us. We will use going to use the torque current square proportionality. T equals K3 by 2 pi times I square.
Okay.
So T equals K3 by 2 pi times I squared. Now we know this I nominal is 70 amps at 1500 RPM.
Mm.
At 1650 we need the current.
Yeah.
Let us take it as I1. UT remains the same.
Mm.
UT equals I1 RA plus K3 N
K3 I1
N1 I1.
I1.
So I1 equals UT divided by RA plus K3N1, which equals 220 volts. No, it's not. Is it 220? It is. RA is 0.163 ohm. 0.163 ohm. K3 0.119 ohm second. Multiplied with 1650 by 60 1 by second. So it's also ohms. We're getting volts by ohms, which is exactly current.
64, yeah.
0.163 plus 0.119 times 1650 by 60. 64. Okay, now we're on the right track. 64.1 amp. Then we can directly use the equation. Torque equals K3 by 2 pi times I square. K3 is 0.119 ohm second divided by 2 pi multiplied by 64.1 amp square. So ohm times amp is going to give us volt. Then you have volt amp second, which is the unit of torque. So square times 0.119 divided by 2 divided by 5. So now I am having 77.6 Newton meter. I have to check why that method is not working. It's supposed to work. Yeah. So now we have the correct torque, and with this we can easily get the power. So P equals 76.6 Newton meter multiplied by 1650 by 60 into 2 pi. So this will give you the power.
Okay, and then there is one question, that one, a centrifuge with the torque above.
Yes, yes, this I have a proper solution for. I've done this
I
previously.
was getting 8.25.